Hello everyone, and thank you for signing up for this complimentary webinar by TUSU on addressing new challenges in automotive safety by integrating ISO 26262 with SOTIF and cybersecurity. Functional safety is one of the most important topics in automotive industry. It is thus imperative in automotive supply chain to design products in compliance with ISO 26262. And while the industry is traversing towards maturity in conforming to ISO 26262, there have been challenges for addressing the safety of the intended function SOTIF in accordance with ISO 21448. In addition to this, hackers have also proved how the vehicle can be controlled remotely in a manner that is contrary to the driver's intention. This demands cybersecurity addressed by ISO 21434 to also be a part of automotive safety. In this complimentary webinar, TÜVSÜD's expert will take the participants through a short presentation to discuss a possible approach to address functional safety, SOTIF, and cybersecurity with the help of the released standards. My name is Astha and I will be your moderator today. Let me take you through the house rules for the webinar before we kick off the presentation. Please connect through LAN instead of Wi-Fi for better connectivity if available. Please connect to the audio by click on Connect Audio button and select your audio connection from the drop-down list. Kindly note the host has put you on mute to avoid any disturbance. Though we are using technology for our advantage, there may be a time lag between the slides. The expert will try to adjust the slides. If you have a problem, please mention it in the chat window. Please use chat option in the Q&A window to ask questions during the session. We will log all the questions and the expert will address them during the Q&A session after the presentation. We would like to invite you to take part in our poll question, which will be posted during the webinar. Now that we are aware about the rules, here is a quick introduction for our speaker today. Our speaker for today is Dr. Chitra Tyagarajan. She holds a PhD degree from the Indian Institute of Science, Bangalore, MS from University of Georgia, Athens, USA, and MSc from Bangalore University in Applied Mathematics. She is qualified as AFSE, Functional Safety Expert, from TUG SGS, Germany. She has worked with Defense Research Development Organization DRDO for 28 years in the field of safety, reliability, and modeling and simulation of weapon systems. She joined Satyam Computers, which is currently Tech Mahindra, for 16 years with main focus on automotive safety. In this tenure, she has worked with several automotive suppliers and OEMs across the globe. She also worked with other verticals like aero, rail, oil and gas industry, and consumer electronics on safety and reliability. She started working with TUSUD since March 2014 as a trainer for all the functional safety standards like IEC 61508, IEC 61511, ISO 26262, and EN 5012X. Currently, with more focus on automotive, she also supports TUSUD in functional safety process implementation and support on functional safety assessment activities for their customers across India. She has delivered functional safety trainings for Bosch, L&T IES Bangalore, ABB, Infineon, Synopsys, Intel, GM, Dalmia, APTIF, KPIT, Tata Elxsi, Harman, Nissan, Tata Motors, Maruti Suzuki, DCA Automotive Singapore, IMI Philippines, and several open house programs conducted across India and Asian countries in functional safety. So on that note, I will hand over the presentation to Dr. Chitra, who will start with the introduction to the topic. Over to you, Dr. Chitra.
Thank you. Thank you, Astha, for the introduction on the topic and as well as my profile. So welcome you all for this short webinar on this particular topic on the integration of the functional safety with SOTIF and cybersecurity. So in this short webinar, what we cover is some of the introduction with some of the advanced technologies, and we talk about the SOTIF and how it is working with us, and the glimpse of the ISO 26262, and then the need, why we need the safety of intended functions, and how cybersecurity also becomes important, and finally closing with the remark of certainly there is a need for integrating all these three aspects when we are working with the automotive functionalities. So moving to this slide on the introduction, like automotive is one domain where we keep listening to many features and functions so often. And with continuous advance in the technology, we have more of the electronic and programmable electronics content in any automotive system. Way back, we had when I really joined the automotive industry, I had seen the brake systems which need to work for the stability control, and this had nearly 18 to 20 functions, and had to really solve 18 different hazards to come up with the safety case document. This was really interesting to know at that point of time, is there so many functions which we need in a brake system? And today, no more, we are wondering like that, call it ABS or hill assist, that is part and parcel of any vehicle we are buying with the current technologies. Now, this brake system and steering system and the powertrain, they have almost sort of reached a maturity in its state, but we are now more with the driver assist functions, because most of the accidents we feel it is due to the drivers not being attentive. So the ADA started with the driver monitoring function to start with, but today we have several functions in the driver assist function to extend this driver monitoring with the lane keep assist and emergency brake intervention, and probably the driver drowsiness monitoring and blind spot detection. We have so many. So the ultimate goal now, though, is an autonomous driving machine without the need for a human being behind the wheel. So that's our ultimate aim. And of course, go green policy, we want to have the electric vehicles and connected cars. No more we want to think the car as a vehicle which is taking us from one point A to point B. We are making it a kind of an office even to work with that. So connected cars, connected with the Wi-Fi technology, like it is connected to the smartphones and the laptops, and the technology is really growing actually. So with all this in mind, what does the customer or the consumers, what is their expectations? We are driven from the media news and other things, and then we keep listening to many of these things. So consumers feel that when they go to these, when they have these functions in the vehicle, they would like the cars to behave exactly like how they would have driven it with any of these assist what the functions are providing. So he would go for these things only when he is really assured with the performance and as well as the safety. So this tells us now all these technology, what we are talking about, this is all under one umbrella, which is functional safety. And functional safety is the integral part of automotive industry. No more it is a buzzword, and anybody in the entire supply chain of the automotive industry, they have to understand what is functional safety and they have to apply it on their product. So this is the current strategy, and most of it today, everybody is trying to put this in their process and then use it in their developments and testing and whatnot. Now, when we talk about these functionalities, what are the three things which comes to our mind? One is the functional safety, absence of unreasonable risk. Unreasonable risk in the sense, like I'm asking for a braking function, it applies the brake and does not apply the brake when I do not really request for it. So that is an unreasonable risk I do not want to have. Okay, having everything done and the instructions are given for applying a particular functionality, I would like this function is safe in its application. So that is operational safety, what we think about during the application, how we would really make sure that the function is applied in the right way, and then we are really not having any hazards due to it. Now, over these two things, every time when we request a function, we would like this function is from the driver's intention, not from a hacker's intention. So this calls us that the cyber security. So the current vehicle, whatever functions we are thinking of, it is really needs to take care of a functional safety as well as the operational safety, which I call as the SOTIF, which is the safety of the intended function, and cyber security, of course. And all these functions are from the driver's demand, not from the somebody who is outside. When we talk about as a safety, this has three pillars, whichever safety we talk about: the safety policy, auditing and assessment, and execution. So what do we understand by safety policy? Safety policy is a framework what we do. Like we list, these are the activities which we would like to do. And this is the way, these are the work products required. These are the analysis and tasks which we require. So we formulate a framework. So having done this framework, we want to make sure somebody, whoever is using this has really used it in the way it is written. So we would like to have auditing to make sure the process is followed, and assess the product, also have a process for assessment so that make sure this framework has been implemented in the product. And execution, to execute this, we certainly require the competent people, and then we need to have the right competitiveness in people to make sure the policy is applied on the particular product what we are working on. So as all of us, many of us who are in webinar, you must have gone through this ISO 26262, and this embodies all these three pillars in it. And that is that especially there has to be an independence between these three pillars, certainly established by the ISO 26262 process. So let's have a glimpse of what is this process, ISO 26262 process. Like we start with this is level of abstraction is always from vehicle to the component. So in the vehicle level, we always address a function, we define a concept of function, and then we come up with the concept phase after assigning the functionalities, we come up with the functional failures, and going through a hazard analysis and risk assessment, we make sure that we assign the risk associated with that. And the measure of risk is through the ASIL, which is automotive safety integrity level. So it could be either A or B or C or D, which means A requires the least safety requirements and D requires the highest requirements. Additionally, we also have a quality management level, which tells we need not really come into the purview of the ISO 26262. So based on this, we formulate a safety goal, which is the highest level of a requirement in the vehicle level. When I talk about a driver monitoring system, I do not want this driver monitoring system to activate something when the driver is really driving with all his attentiveness on the road. So that is the requirement which I formulate at the vehicle level. And this leads us to think about functionally how I should achieve this. That is my functional safety requirements. Then I go into how to implement them and the hardware and software which I require for this. This comes as a technical safety requirement, and we conceptualize this technically. That is my technical safety concept. From there, I derive my hardware related requirements and software related requirements and follow all the rules for the design, testing, everything within the standard. Then go for my integration testing. So the integration testing, I have the hardware software integration where I realize my ECU. Then I go for a system integration testing where I make sure that the electronic control unit ECU works in the environment for which it is made, connecting the actual sensors and actuators, that is realizing this function as an item within the vehicle. Then vehicle integration testing, every ECU actually interacts with the other ECUs, like probably the lane keep assist, which I talk about, it has to interact with the power steering ECU. The brake intervention ECU has to interfere again with the the brakes ECU. So these are things which are tested with the vehicle integration testing. Then finally, the safety validation, where we want to make sure that this vehicle, when it is running in all the maneuvers which we consider during our hazard analysis and risk assessment, so this would make sure that the design what has taken care of all the safety related issues, then we can make sure that it is running and the controllability is established. Okay? And finally, we go for an assessment to make sure that the everything is done with as per the ISO 26262. We also make a safety case document and assess the product and then release it for production. So in addition, it also looks at it also makes sure that some of the management related supporting processes are available here. So we have the functional safety management and supporting process also as part of the ISO 26262 standard. So this is the complete framework what it has, and it can really follow these processes to implement safety. So as we have seen, coming from the function to the architectural elements from the functional point of view and the implementation point of view, we are looking at several failures which can lead to not really, achieving the functionality. We look for these things and come up with the mechanisms in terms of design or mitigation plans to make sure that the driver is informed when there is a malfunction, he can take an action appropriately. So this is the general framework in which the entire ISO 26262 is working actually. Now, we want to know that whether this is sufficient, the 26262 standard which is now widely followed, is it sufficient to really take care of all types of the functions which we have talking about? So consider some of these ADAS functions like lane keep assist or the emergency brake interventions. And even though the hardware and software are working right, there can be certain safety issues and when the intended functions are getting activated. So let's go through a couple of things to understand what are the real difficulties. Even though everything may be working, what could be the challenge in getting the intended functions to act as per the driver's want? So consider first the lane keep assist, where the car is expected to keep the distance between the two markings what we have equidistant. So it is traveling in the middle of the median of these markings what we have. So is it possible? Will it always work and really move in that? Probably it will move to the left a little bit and maybe it has to correct and then bring back. And again, it may go to the little right and then it has to. So this could happen because of the latency in the control systems, which is a feedback system. And certainly one has to make sure when you are designing these things, how you are testing it with the key performance indexes. The other thing which we can talk about is it must be able to maneuver through construction areas where there may be a deviation from following the markings what is given in the road. So is the system adaptable to really get into the maneuvering to the construction type of lanes what are shown here? And think about the other function like adaptive cruise control, where we think about again, if every car has the ACC put in that and all the cars are using, imagine there is no other obstacle coming in between or anything. They're all moving in a peaceful lane. And if all the ACC controls ECUs are working fine, we must be able to maintain this distance equal. So the relative distance between all these cars must be constant. Will it really happen? But practically, unless they are so well tested and then the latency is not occurring, then it can happen. Imagine the second car really slows down a little bit, then we will have some distance more than what it was. And with this effect, the distance between the second car and the third car will reduce. So if you keep imagining this kind of a latency happening, it can happen in some point of time. The cars are more close to each other, and at some other point, the cars are more distant from each other. So this we call as an accordion effect build-up, where we have to really make sure how these kind of latencies can be avoided. So here, as you see, from the ISO 26262 when I'm coming, it is the sensor data or anything, everything is working fine, but within the latency built up in my control systems, this can happen. So this involves a lot of testing and making sure how much of deviation I can allow and how it should really take care of it. And regarding the emergency braking intervention, recently I had seen an article where some of the autonomous system, what they are thinking about, is not able to avoid the parked cars. So probably the parked cars machine learning is not so appropriate here. So it is not able to avoid the parked cars, whereas the other moving vehicles it is able to avoid. And think about the optical illusion thing. Some of the areas you may have a picture like an optical illusion kind, where it is not actually the child is really coming with the ball, but this kind of a thing is done so that you would really slow down the vehicle in the school areas. So will my system differentiate between this and actually a child coming and then playing the ball there? And also during this time, it should not mistake it for really a child coming with the ball and then apply the brake in all might actually. Can the vehicle really distinguish between a static object and a dynamic object? Okay, yes, a skateboard, which is waiting as a pedestrian, first it may take it as a pedestrian, and suddenly the skateboard starts moving with full speed. So how will my system adapt itself to really apply the brake? Okay, so these are all some of the things. It's not really related to the architectural element which we have for realizing a function. So this depends on the actually how much we have thought about these things in building up our systems. So the 26262, this concerns more with the mitigating risk due to system failure during the activation of the function. And SOTIF applies to the functionality that requires SOTIF means safety of the intended function. And we want to make sure that with respect to the situational awareness. So when we think about this infrastructure in driving, or if you look about the aerospace industry and the rail, we have the fixed infrastructure for these things to move. Whereas for automotive, we have several types of obstacles and other things which you have to consider in a drive, in an urban drive or in a highway drive or anything like that. So there is always more challenges here. So what are the things which we have for realizing these kind of scenarios? Some of the enablers are artificial intelligence, machine learning, neural networks, and deep learning. These are some of the key enablers in the ADAS industry. Thus, we have the standard which has come for the safety of the intended function, which is 121448. This complements the ISO 26262. So what is SOTIF? This is absence of unreasonable risk due to hazard resulting from functional limitation, that is use cases what we have considered of the intended functionality when applied in realistic environments like the urban scenario or a highway scenario, that's a realistic environments according to a designated use case or in a case of reasonably foreseeable misuse. So certain times probably the driver can misuse if I have not given proper instructions and things like that. So this could be the causes for a safety of the intended functions. So what is the difference between the functional safety and the SOTIF? Already we know that the functional safety works for malfunction resulting in a hazard, whereas and also the approach what we take in the functional safety is starting from the vehicle level requirement, which is my safety goal, And it's a linear approach. I come to functional and then go to technical, and then so having really defined these things when I go for a release for production, I am really confident for a given function and a given architectural elements in realizing this, I have really achieved it. But when I come to the SOTIF, it focuses on avoiding hazards due to performance limitations, not being able to comprehend the situation, environment like a weather or road infrastructure, inadequate robustness in the build, what we looked at as the latency in our control systems, not able to comprehend due to the secondary effects of the latency in the control system. This is the thing. So these are things which is becoming, and it is more an iterative approach. So anytime when I am releasing the product, it is only with some confidence level to the extent of what all use scenarios I have taken, my algorithms would work. And the limitations of these sensors and things with respect to the environment, what I have considered, that would work. So with certain confidence, I would release. And then in case if there is an issue, I might have to come back again for rebuilding or modifying something within my entire development. And also, this talks about safety measures may support several safety goals and allocate across the item, because it is not the safety of the intended function is not related with only one ECU I defined for a functionality it is working. It is dependent on a brake system. It is dependent on a steering system. It's also dependent on a powertrain system. So there are interventions between so many ECUs here, which tells we have to look at the safety measures, not to have any conflict in the safety measures also. So this leads us to define 4 different areas, like 4 areas of use cases, where we have the known and safe scenario. So almost we know these are the things and I will take care of it, and the design has taken care of it. And the other thing which are, there are scenarios which we know this is known and we know that it is unsafe, but it is known to us. These are the different things, and probably my algorithms might have to take, for example, let's take, we know the camera sensor limitation. Under this light condition only, it can give me the right frame of picture. So if the weather condition is not good, if I have something to determine these things, I would make sure that this is disabled and other things are only working for recognition of the object. So this is known and unsafe scenario. So I have already thought about these things and implemented it as a mitigation or control within my design. The other thing is the one which is challenging, is the one which I have never thought about it, and probably it comes out as a surprise when I'm really using the function on the road. So that is my unknown and unsafe scenarios. This is the real challenge. How would I really make sure of these unknown and unsafe scenarios are minimum in my development? To the extent possible, we must be able to make this region as small as possible to move into this at least area 2. So the entire application of the SOTIF is aiming at to bring the area 3 to the minimum and move with the area 2. Preferably if we are in area 1, it is really good. And the area 4 is of really no consequence. For completion of the 4th quadrant it is when it is unknown and safe scenarios. It doesn't bother us with respect to functionality. So how does the SOTIF work as per the, just I will give a glimpse of process which is within the 21448, similar to what you go through the concept phase and the item definition, all those things we go through. And we look at the hazards and then we see it is a SOTIF related hazards. That is, if the function is not working as per the intended request, what can happen? Will it really cause the hazard? Yes. Then the risk is there. What I will have to look at it is not from the malfunction of my components. I look at it from the other scenarios. What are my triggering events? What are the things which can trigger this event, trigger this function to go into a malfunction which will not do its intended function? So identification of the triggering events. Then I look at it whether it is all acceptable or I have to go and do some modification, these triggering events, I have to really make sure my function definition itself has to change. Maybe I have to go and okay, it is acceptable. It is something which can really avoid and take care of it within my algorithms and design. Then I come here for, I define how I want to verify these triggering events. I validate these things for the safety of the intended functions. So the known scenarios are sufficiently covered and the system and components behave as expected. So this we do the verification. Then once we are satisfied and we have the confidence that yes, all the things what I have considered is working fine. And then I come to really driving this with the real scenarios where probably I can come up with some of the unknown unsafe which was there, which I can bring it to my area 2. So the process is defined in 3 blocks here, the evaluation and analysis first, then where we have the known and unsafe, where I can take care of it, which is area 2. And the third thing, which is area 3, where I don't know, but by running these functions in the real scenarios, how much of these use cases I can really move it to area 2. So these are the 3 broad phases which are defined here. And the main challenge is the verification of all these things. We require more of a traffic data, and we require more of a simulations and statistics to formulate these distributions and then test our things. So it is not very simple to just look at, okay, these are my functions and this is my input. It involves more time in verifying these things to make sure that the intended function will happen without any of these problems. The triggering events are really taken care of within my development. Okay. So what are the challenges? One is the identification of the triggering events. That is one of my thing, like probably the triggering events I can think like for sensors. It may be blocked due to some dirt or ice or snow. Have I taken that into account? Or probably the light on the camera, is it too much or it is okay to take the pictures? Have I considered all these things? Or any of the noise factors, the EMI noise factors for my radar sensors? And any of the special road conditions which really affect the algorithms, whatever I am writing, like driving scenarios, have I taken care of the accident areas and the construction areas? All these things will form something in the learning mechanism which I have here. So these are the certain challenges in validation, because unless I have really identified these scenarios, I will not be really able to validate my development, the design with respect to these things. And systematic way of hunting for the area 3, that has to be formulated by really running it for real scenarios and then collecting the results. That is the real big challenge here. So that ultimately we want the area 3 where I have unsafe and unknown areas minimum, so that I will be able to release the product with respect to some confidence level. And with respect to development, when we go through, we have other challenges. As we know, the 4 enablers which we mentioned beginning also, these are the things which are artificial intelligence and machine learning, neural networks, deep learning. These are the enablers here. And this certainly requires a lot of data acquisition and data processing for the machine learning algorithms actually. So when we come to that, then we would really like to take the help of external resource to do these things, because the time has to match and then something has to process and give us the result in the right time for the activations. So given the complexity of this urban scenarios, what we have, where we have to drive the car, for methods mentioned, this requires a high computation resources. So there are some articles here now where they have come up with how they use the cloud for getting all this processing done offline there, so that we can access the cloud for getting the proper scenarios and instructions. So one of the challenge may be a network latency here, which can become another factor in decision making, like a lane change command or obstacle avoidance by braking. It may get delayed. So there is always a some kind of a challenge here. And having done okay, probably we are able to manage all these things. And now we really think when I'm using something like this cloud and other sources, how much I'm able to save it from the hackers getting into the actual design ideas and the development ideas what I have. So this now leads us into the cybersecurity. Okay. So it is not only when we are using the cloud or we are using some external or network, I will have this problem of the cybersecurity threats, but many people, the hackers have already proved that they can take a control from everything from a car's brakes to its door locks to computerized dashboards, displays and accessing the onboard computer through GM's OnStar and Ford Sync, as well as through Bluetooth connections intended for making hand-free phone calls. And they have also proved that allows the driver to make hands-free and phone calls. They found a vulnerability in the way Bluetooth system was implemented that allowed them to execute code to take control of the car. So there are several things which can happen even without using your cloud or something. Somebody can get into the OBD port and then start reading the CAN message signatures, and they can certainly do something from the outside. So these are things, and then of course they say now in the research says that the car could learn to recognize hackers. So probably if you keep track of the traffic track, if you track the traffic within your computations and things like that, probably we can identify that it is happening due to hacking. So new software protects like autos against hackers figuring out what normal and internet traffic should look like. So these are the some of the things which are going about. So what do we have in place for looking at a process for this is there are two standards which were established like the SAE J3061 and we have the other one ISO 21434. This is a draft version which came in February 2020. And this gives a sort of a definition, like in a systematic way, like how we go in the ISO 2626. I pick up the word ISO 2626 because many of the people working in the automotive are quite familiar with what we do there. So by and large, the process really parallels with what we have learned in the functional safety standard. So also when we are thinking about a security, we may come across the security and safety complex, the functional safety, many of these things where we think about a safe state. It may be that the safe state is gone, its car is getting into a safe state because of a particular failure, or this failure was introduced by somebody. So for example, we take the status signals from different ECUs and make sure the ECUs which we require are in working condition. So from functional safety point of view, we trigger safety mechanism based on the status signals. So for example, if we do not receive the status signal from airbag ECU, to be on the safer side, the doors are unlocked and the intended function, and we also intimate the driver that it is not available to him. But let us say the airbag control unit is working fine and somebody initiates this off the line and the doors gets unlocked. And this can cause a kind of a thing if we have the doors unlocked when we are driving. So this is one way what we have as a safety mechanism. If it is getting hacked, it may really get into a problem for a situation where there is really no malfunction from the functional safety point of view. So what is the process involved here? We have the description of the system. So the detailed architecture when I can go through this architecture and identify what are my assets. So asset identification is one of the first activity I do. And associated with the asset, I also look at what are the threat scenarios here. And these threat scenarios, the damage, it really gets connected with the damage. whether I'm going to have a loss of function or I'm going to have a delayed signal because of that time the function will be delayed. So I look at what are the damages which is related to a threat scenario, and also look at what is the impact based on this damage. I look at the impact. So the impact and risk, they get associated with each other. I would look at it whether it is a safety related or operational related, or it is going to be a privacy of the information going away. So these are things which I would look at it here actually. Then once I know the threat scenario and the assets here, I look at the attack path. Like this is the way it could be attacked through some of the paths in the car. And what is the feasibility? Like what is the feasibility of this attack actually? Is it really possible or it is not possible? So there are certain factors, and then we have attack feasibility modeling here. Then we come up with a risk determination. So finally, the risk will identify what is a cybersecurity goal, and then how I want to make a design to make sure with the to really to the extent possible I can avoid these attacks. So just let's look at in the automotive scenario that some of the small examples to understand each of that. Assets, when I am saying it is from the system architecture, any component in the architecture, any elements in my electronic and electrical systems, might be a CAN frame, maybe a firmware. And when we are thinking about it, and we have to also associate the cybersecurity property to it, and is it really affecting my confidentiality of this, or it is the integrity of the function is getting lost, or the function, the availability of my function is not there. These are something which I have to associate with each of these assets. Then the threat scenario, probably the CAN bus can be loaded with higher priority messages and intended functions message may be delayed. This could be one of the threat scenario. And there could be a loss of function, the damage, or the delayed function, or an unintended function. When we talk about the attack path analysis, is it through the gateway ECUs or OBD2 connector? And is it through a Bluetooth interface? These are the attack paths actually. And feasibility, again, I would rank it as high, medium, or low, or very low. And this is again based on expertise of an attacker, how expertise he is, and knowledge of the item, how much of the knowledge he has gained about the item, window of opportunity, and elapsed time, the time to know the vulnerability and then apply the exploit. So this is something which we look into it, and all these things together, we come up with the risk determination, where the risk is evaluated, the damage and risk they are associated, and it is with respect to safety, financial, operational, and privacy. This is a very popular term, SFOP, which is normally used with the cybersecurity. Then we think about how I would like to really risk treatment. I look at it, how I would like to reduce this risk and derive the cybersecurity goals at this, and then come up with the similar lines like what we have in the functional safety standard, cybersecurity concept, and then how I want to do this. And when testing comes, apart from the requirements-based testing and other testing methods, which are also listed in 21434, we have additionally the penetration testing and the fuzz testing, which all these becomes more time-consuming activities to make sure that the product is really free of hackers attacking the particular functionality. So again, we can think about this got me an idea. We can again think of four areas here, the use cases, the known and safe vulnerabilities. So what are the vulnerabilities? Probably I would have taken care of certain vulnerability by the passive methods. Now, the known and unsafe vulnerabilities, probably I will have to think about some of the active methods, like how I will have to take care of these things, the controlling and mitigation, those things can be thought about. Again, the risk what we will have, or the challenge what we will have, will be the unknown and unsafe vulnerabilities, where I do not know what is the vulnerability, which something which is rather, if I have to really identify everything, I must really think like a hacker. Then only I will come into all the time into area 2. perhaps I have a limitation from the when I am as a developer. So that is one thing we must have a cybersecurity team, and as many of you know, that the functional safety also intends that there is a communication between the cybersecurity team and the functional safety team. So these kind of things would help us to keep this unknown and unsafe vulnerable. And how do I build the solutions? Probably some of the defensive things. I have the defensive and offensive techniques so that I can improve the cybersecurity in vehicles. So defensive implies like the password protections, and then probably the two-level password protections I can think, which we normally have with respect to our IT related things. We can think about such passive things, and the offensive implies the active. So based on what is the path that actually the attacker is taking. So if the path is attack path is known to you, where you would really like to put some barriers to check, and then because if we start putting a barrier at every point, we also have to compete with the real-time computation so that we are able to really get the functionality in the right time. If I have too many checks, and then it may also be a challenge for me to activate the function when I really require it actually. So the offensive implies a systematic way of really looking at it from all aspects and looking at the attack path where you would like to really take actions and then build the mitigations and the controls. So this is something which is described in the 21434, and then this process can be really followed, and almost it has one-to-one correspondence with the ISO 26262, and we can really go parallel. So as already mentioned, the main challenge is 26262. Yes, we are looking at the malfunctions, and we are able to build the methods to avoid a functionality, taking to a safe state and all those things that is known to it. But in the SOTIF and cybersecurity, it is not a completely, guarded product against the intended function and the cybersecurity attack. To the extent possible, whatever is available at that point of time, but at least that we have to make it exhaustive so that we are able to reach the product with some amount of confidence. So finally, I would like to conclude saying that we have this integration of quality, functional safety, and cybersecurity. This could be the V. Of course, I have missed out one V here. The A-Spice V also can be put along with this because that is also getting popularized not only with respect to software, and the system level things are brought in that nowadays. And IATF 16949 is something which the auto OEMs are preferring all the supply chain, the entire automotive supply chain to use that. And this talks about 16949 and ISO 9001 in the integrated fashion. So that's my quality V. And I have my 26262V and my security, which is coming cybersecurity 21434. And along with that, I have my SOTIF V to go along with that. So ideally, probably way forward when we have to really have the maturity and then release these autonomous functions, probably we have to think about having this integration in place. So with this, I would like to close this webinar and it's open for questions.
All right. Thank you, Dr. Chitra, for the presentation. We will now begin the Q&A session. At the same time, I would request everyone to please take part in one more poll, which will be posting right away. Meanwhile, we take up the questions. So, Dr. Chitra, here's your first question. Since SOTIF is an iterative approach, at which phase in the product development lifecycle SOTIF analysis is expected to be frozen?
SOTIF analysis, as I explained, it cannot be frozen, but it has to begin along with the hazard analysis and risk assessment, which we do in the functional safety. So there we are getting more with respect to what is causing the hazards from the design perspective, but here the threat scenarios, what I explained, so it has to go along with that actually at that point of time.
All right. Here's your next question. How do a certain area 4?
Huh? Oh, I
How
didn't.
how do a certain area 4?
Area 4 is not, it's for completion's sake, it is written. Actually, it is not really affecting our system. It's known and safe. So it's not really something which is going to attempt, get into the functionality or hazardous situation.
Okay. Here's your next question. When you don't know something, how can you say it is safe?
Don't know something, we know the function. For example, the context here is a function which I require during my driving. So that is exactly what I am looking at it like. What are the ways I would, or what are the situation driving scenarios, which is my situation analysis, which I talk about. And I can always think about if this function is not working in the way it has to. So that is something which is of unsafe thing to me. So I will have to avoid it actually.
All right. Here's your next question, Dr. Chitra. Knowledge of hacker improves as technology evolves. How we should incorporate safety improvement to product back?
So one thing I have heard in one of my teaching sessions, like the car manufacturers, they have, I mean, like we have the certification courses here, we have certified and qualified hackers. So better to keep them as a part of the development team so that you will be able to know, he will be able to help. At least when you are releasing the product, he is the one who has to, not he means not one person, probably a team, can assure that all the sneak paths for a cybersecurity related thing has been controlled. So that's the only way we can do about it. Otherwise, person who is designing, he may not be really knowledgeable on the hacking and how hack, or keep it open for hacking and then see how all it can be hacked. That is another way actually. Keep the system open for some time and then see how so that you really before release you see that in one of the your versions, beta versions or something, and see that whether how the hackers will really get into. That's another way I have seen in literature.
Right. Here's your next question. Is there any standard the vehicles are certified that that a particular vehicle followed all the cybersecurity development process?
For prefer has just emerged, and then it's a good framework which has come up, and currently what is released is the draft version what we have. And I don't think even I don't think any certification will be available very soon for this, because as such there is no mandate for following the 21434. And probably when the final version comes in, which is expected probably towards end of 2020 or beginning of, it was expected, but probably beginning of 2021, then probably these certifications will start. But it will take a long time. Even today, how many products are getting 26262 certified? We are doing assessments, but we are not doing any, I mean, even assessment for that matter. It's a more an internal thing, and we haven't gone through it yet.
All right. Here's your next question. How to perform validation of known scenarios?
Or the validation scenarios actually based on the triggering events what you have considered. So the finally to consider all those areas and once it is done within or all these by simulation and other things, we will have to drive the car in those scenarios and really with the obstacles and other things, what you have really considered, that's the only way we can do the validation. There are tracks actually, when there are for checking autonomous driving, there are tracks which I have heard that you do keep these kind of obstacles and then say how quickly it takes a deviation. So it can be validated that way.
All right. Here's your next question. Does ethical hacking come under offensive technique?
It's a passive.
All right. Here's your next question. How to deal with conflicting timing constraints of safety and security? Like we may need to act very quickly, but it may be delayed due to encryption or authentication for security.
Can you repeat the question, Asta? I couldn't hear you.
Sure. How to deal with conflicting timing constraints of safety and security? Like we may need to act very quickly, but it may be delayed due to encryption or authentication checks for security.
What I the active methods when we are going, it can throw some of the challenges for us. And then let's say the path, the attack path we saw, let's say it is a port 1, port 2, port 3 like this. And finally, the functionality is going to be activated only after port 4. We may have to take really a design kind of a review where I would like to put the checks by putting in last one, is it good enough? And that kind of an analysis has to be done. There are several, I mean, these kind of things are really not said in the 21434, but one has to balance it so that we are able to not to lose the functionality in that. That is the major challenge actually.
All right. Thank you, Dr. Chitra. Here's your next question. Do you think that smart cities can be used to simulate attacks?
Probably.
Hello?
Yeah.
Here's your next question, Dr. Chitra. Do you think that smart cities can be used to simulate attacks?
Yeah, I said yes. It can be.
Okay, here's your next question. Can you give an example of how to integrate a security goal and a safety goal?
Yeah, we cannot integrate the security goal and the safety goal because the security goal, what I am making, it is with respect to, I provide a value based on whether it is a safety related, the same thing. It may be having more weightage towards the safety, probably less weightage towards anything, because when the safety, we think about only safety. But the cybersecurity thing, let's say it has more weightage with respect to privacy. So I may have to balance it, which is really important. What kind of a privacy matter is going? If both are only the maximum is only the safety related, the cybersecurity goal also says it is more towards the safety related thing, then probably I can integrate it. But we cannot integrate the two goals without analyzing these factors.
All right. Thank you, Dr. Chitra. Here's your next question. How can Tier 1 integrate a technical safety concept and technical security concept?
With respect to their ECUs, they have all the elements which are getting into the system and then study through that. With respect to that ECU, again, the boundary comes in. They can take the responsibility with respect to what they are designing. Exactly very similar to what we are talking about in item definition in the ISO 26262. We will have to make, we can think about the elements responsible here and which can be cybersecurity prone, and then we can take it, not beyond that.
All right. Here's your next question. Is mechanical function in scope of SOTIF, or is it a constraint to EE systems as in FUSA?
No, mechanical systems also can be a part of the SOTI. I mean, we are not, uh, for that particular situation, let's say if the output involves a mechanical system also, then probably, because we are not thinking about a safety or unsafe things created by that. But yes, probably if I have to redesign to take care of certain situations in the road, yes, mechanical systems. But currently, anyway, standards are talking only about the EE systems. But in my own perspective, I feel probably mechanical because still 70% of the automotive is still mechanical.
Okay. Here's your next question. How to decide which triggering event needs functional modifications?
No, that we cannot. We have to do an analysis. Like probably, let us say, a small example I can take. The sensor what I am using is very critical. I mean, I am using it for getting object detection, and it has its own limitation. Probably it will not work for all the situations. Probably a lidar sensor which cannot go beyond some type of obstacles. So probably then I will have to think about, do I want to go and then modify this function for something else?
All right. Here's your next question. While developing something to meet SOTIF, is it required to meet ISO 26262 and SAE 21434?
Yes, I mean, that's exactly what we are talking about. There is no mandate from anywhere, but when I am releasing a function, I would like to make sure that it is functionally safe and cybersecurity safe. Yes, we have to have both.
Okay. Let's move on to the next question. Are there any methods to ensure maximum identification of triggering events in SOTIF?
They recommend some simulation in that 21448. It's well written. The appendices are the real wealth of the 21448, and that can give us some ideas like how, when we are really simulating with the traffic data in place, that must be possible to do it.
Okay. Here's your next question, Dr. Chitra. How to define criticality of requirements of SOTIF? Is there anything similar to SL level in SOTIF?
The so again, what are like, for example, the algorithms and the things like that. Suppose if I am able to recognize the difference between, for example, a simple example, applying a brake to stop in front of a particular obstacle, or something related to the optical illusion, what we saw. And that's one small example where we have to, these are the requirements normally we will put in actually. And with respect to the inputs, we will have to take all the other conditions and the requirements. Maybe in certain conditions, if the sensor is not going to give me the right input, I have analyzed it, then that becomes one of my requirement to make sure that if the other conditions are not suiting to get the right input, yes, probably I will have to stop this function or something. So these kind of requirements can be written based on the triggering scenarios. But exhaustively coming up with the triggering scenarios is very important.
All right. Thank you, Dr. Chitra. Here's the second last question. As a PSM of a project, how or what is the decision criteria to decide if 26262 is sufficient or SOTIF also should be implemented, or it's informed by the OEM?
It's not a VM may inform you, but depends on the functionality. As I told, the matured functions are now this is not really getting applied to the braking, the three major functions, the like braking or steering or the powertrain. But any driver assist functions where it is involving the machine learning and the scenarios on the road and things like that. So it certainly goes through the SOTIF. So it's not really be driven by somebody. I mean, individually, I would always tell this to everybody like, when I am doing something, I would like it to work for all types of things. It need not be dictated by somebody. So wherever the ADAS related functions are coming up, it is at least advisable to start with the SOAP.
Thank you, Dr. Chitra. Here's your last question. How to include cybersecurity into the existing item definition?
We not include cybersecurity into that. It starts after once you have all the conceptual, your system architecture is there, we can extend it in terms of at least first stage of identifying all the assets and that, so that we can, that can become our lead for getting into the other analysis and coming up with the requirements.
All right. Thank you, Dr. Chitra. Well, we have a lot of questions, but due to time constraints, we will not be able to take any more questions for the day. If you have any more questions, please write to us at your respective country inquiry IDs. We will answer them for you. You can also write to us on the same email ID if you want a request for webinar about our offerings. I'm sure this webinar was interesting and relevant for all of you. Please do visit our website where you will get the latest news and updates on functional safety services. Thank you once again for your time and have a good day.